Figure number 4 shows a partial front view of the roller coaster path in replica park. The curve of the roller coaster path is represented by the equation y equals to 1 over 64 x to the power of 3 minus 3 over 16 x to the power of 2 with point A as the origin. The question is look for the shortest upright distance in M from that root to the ground level. So how do we solve this? First, we take the equation given and then we derive it, and then it becomes like this because we simplify it. As the curved area of the roller coaster is a turning point, so we can put it like this and make the derivative equals to 0, and then we take out the x. So we have x equals to 0 and the other equation which we can just solve it, and the answer is 8. So we have x equal to 0 and x equals to 8. After that, we replace the x value into this equation, which was the original equation. So we get y equal to 0 and we get y equals to negative 4. So when x is equals to 0, we get y equals to 0. And when x is equals to 8, y is equals to negative 4. So we take the derived equations that we did, or in other words the first derivative, and then we derive it again to get the second derivative. The second derivative should be d squared y over dx squared equals to 3 over 32x minus 3 over 8. With the second derivative, we substitute the value of x equals to 0 and x equals to 8. When we get x equals to 0 and we substitute it in the second derivative, we will get negative 3 over 8. Negative 3 over 8 is less than 0, so it is the maximum point. When x equals to 8, we will get that 3 over 8 is greater than 0. So the question wanted to ask the shortest distance from the root to the ground level, and we can conclude that the shortest distance, or let's say the shortest point, is the minimum point. So that means the upright distance shortest is 5 minus 4. The 5 is from the height of the roller coaster. When we subtract 5 from 4, we get 1 meter. So in conclusion, the shortest distance from the root to the ground level is 1 meter.